Hello, thank you for checking out A1 Math, and today we're looking at modeling exponential growth and decay. So let's begin. Okay, so first thing I want to do is go over the formulas for exponential growth and exponential decay, and go over a few parts of that formula. Okay, so in the exponential growth and decay formula, y is equal to your final amount, a is your original amount, r is the rate of growth or decay, and t is the time. So you need to find those four components in your formula. So we've got exponential growth with y is equal to a times 1 plus r raised to the t. Exponential decay is y is equal to a times 1 minus r raised to the t. So you could use this to find different things that grows exponentially or decays exponentially, like populations of cities. So here's two examples of populations of the cities of of a city and how it grows and decay. And I'm going to show you how to figure out what's going to happen in the future. So for example, in this first one, it says the population of the city is increasing at a rate of 4% each year. In 2000, there were 236,000 people in the city. It says write an exponential growth function to model this situation. Then find the population in 2009. So this is what you want to do. You want to start, excuse me, you want to start by identifying what your A and R is. Okay. So remember, A is the original amount and R is your rate of growth. All right, so we'll find those. So in the problem, the A, use red, which is the original amount, is here. So in 2000, we had that. So that's A. So A is, let's make this a little bigger, 236,000. All right, now, next we want to find the rate. And the rate is going to be 4%. But we want to convert it to a decimal. So if you take 4% and you convert it to a decimal, you move it the decimal two places. Okay, so 4% is equal to 0.04. So you move it two places, put a 0 here, and you get 0.04. So that's the rate, 0.04. All right, so the next thing you want to do is substitute R and A into your formula. Now, understand this is an exponential growth because we know that it is increasing. So that tells us that it's growth. So we're going to use this formula. So we're going to plug in everything we've got. Okay. So to do that, we'll just say, all right, y, I don't know what y is, that's my final answer. It's equal to A, which is 236,000 times 1 plus, all that's straight from the formula, raised to the rate, which the rate is, I'm just going to put 0.04, raised to the t. All right. So that's going to get us our exponential growth formula for this particular situation. Okay, so the next thing we want to do is take a look. We want to go to step 3, and it involves substituting for t. So t tells us the number of years. And if you forget that, you can go up here and you say time, t for time. So the time here is 9 years. So we started off at 2000 and we're going to 2009. That's 9 years later. So what we're going to put in for t is 9. So I'm going to come down here and write that. And I'm going to substitute y is equal to 236,000 times 1 plus 0.04 raised to the t. Oh, not t, we'll go ahead and put 9. Now we'll pull out the calculator and type that in and see what we get. So I'm going to clear this out. 236,000 times 1 plus 0.04, close parentheses, and raise that to that 9th year. All right, so we end up with 335,901.58 500 5877. Now all this, I mean, since we're talking about people, we're just going to round whatever this is to a whole person, whether it's 5 or below or not. We're just going to round it all the way up to a whole person. So that's going to leave us with 335,902. And that's the exponential growth. That's what the population is estimated to be in 2009. All right, let's take a look at another example. Okay, now we're going to do exponential decay. So with exponential decay, the formula is exactly the same, except instead of plus, we're going to have a minus here. Okay, so we're going to keep the same steps. We're going to um, find the original amount and the rate. And you also want to make sure you determine whether it's increasing or decreasing. So it says here, the population of the city is decreasing at a rate of 6% per year. In 2000, there was 35,000 people in the city. It says write an exponential decay function to model this situation, then find the population in 2012. All right. So you start off with 35,000. It's decreasing by 6% a year. So since it's decreasing, that means you want to use decay. All right, so I'm going to zoom in here. All right, so first thing I'm going to do is find my original amount, my A. So my original amount is 35,000. And my rate, which is 6%, I'm going to convert that and move the decimal 2 places. And now that's going to equal 0.06 as the rate. So I plug that in, 0.06. Now I'm going to substitute A and R into this formula, leaving everything else the same. So I'm going to have y is equal to A times 1 minus my rate raised to the t. Okay, so I'm plugging in my A. I probably need some more space than that. 35,000. And my rate, which is 0.06. Okay, so the next thing I want to do is plug in the time. Remember, the time is years, so I got 12 here. I'm going to plug that 12 in for t. Come down here and rewrite my formula. I got y is equal to 35,000 times 1. Uh-oh, let me go back. Oh, I got that right. 1 minus 0.06, and we're going to raise that to 12. And now we're going to type this into the calculator and see what we get. So I got 35,000. And I'm going to multiply that times 1 minus 0.06, close parentheses, and raise it to the 12th. Hit equal, and this is what I get. This is what they say the population is going to be. So it's saying the population is going to be 16,658. Okay, so 16,658, because we're going to round this up to a whole person. So I'm going to go ahead and zoom out and take a look at the whole problem here. And just to recap, the first thing you want to do is figure out if it's growth or decay, and then identify your variables, the original point and the rate. Then you plug it into the correct formula. Then you plug in the year or the time that you're looking for, and then you type in the calculator to figure out your answer. Okay, now take a look at these three problems and see if you can solve these. Okay, so let's take a look at number one. Okay, so our A here is going to be this 372,000, and our rate is going to be this 5%. And we're going to plug both of those in, and we're going to change the 5% to 0.05, and then we're going to plug the 8 in to see what we get. So what you end up having is 372,000 in for the A spot. And let me write this out. And since they say it's increasing, that means it's growth. So that means we're going to have the Y is equal to the, make sure I write the formula down right, A times 1 plus R raised to the T. Okay, and A is here, and then we got the 1 plus the rate, which is going to be 0.05. I want to raise that to the T, which is 8 years. And when we type that in the calculator, we end up with 549,613. Okay, now we're going to do the second one here. And it's also increasing. So that's going to um, mean it's growth as well. So I'm going to plug in my A, 42,000, and my R, which is 3%. So I'm going to have 42,000 times 1 plus 3%, 0.03. And on this one, we're going to raise it to the 7th. And when we type that in, I'm going to write this right here, you get 5,165. Okay. Okay, so on this one, I think the bookmakers messed this up here because this should be minus. All right, and with this point 0.5, once you type that in, you should get 344,711. Okay, so you got to be careful on things like that. So when you see 6 months, make sure you don't put six. You're going to put point 0.5 because 6 months is half a year. Okay, but that is doing exponential growth and decay. Um, keep in mind, you want to keep your mind what your formulas are. Y is equal to a times 1 plus r raised to the t. And decay is y is equal to a times 1 minus r raised to the t. Make sure you know that the y is your final amount and your a is the original amount. R is the rate of growth or decay, and t represents the time. All right, but for right now, that's it. Thank you for checking out A1 Math. Have a nice day.